Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson. Today we're going to be looking at finding the derivative and second derivative of a relation, something that involves x and y, with the assumption that our y variable here is a function of x, so that we can use implicit differentiation. So to find the derivative means that whenever we pass through a y value, we're taking this whole thing with the derivative with respect to x. That means that we pass through the y, and since y is a function of x, then we end up getting y prime, or the derivative of y with respect to x. So we've got to keep that in mind as we work through this. So we've got x squared y minus xy squared equals 2. And we're asked to find the derivative of this with respect to x. So the first thing we're going to do is we're going to treat each of these terms as a product rule. So the product rule is if you've got two different functions being multiplied together, we're taking the derivative of that. It's the derivative of the first times the second plus the first times the derivative of the second. Sometimes you might see that reversed, but either way, take the derivative of one piece times the non-derivative of the second piece. So let's start off with the first one. So we get the derivative of x squared. So that's 2x times the second plus the first times the derivative of the second. So the derivative of the second is the derivative of y. And I could write that out as dy dx, but to keep things easy, I'm going to write it out as y prime. Minus, now we use the product rule again. So the derivative of the first, which is 1 times y squared, plus the first times the derivative of the second. So we bring the 2 down, and we leave the inside alone. And then we take the derivative of the inside, which is y prime. And then that's going to be all equal to the derivative of 2, which is just 0. Okay, so now we need to solve this for y prime so that we can take the second derivative. So let's go ahead and distribute the negative into that term there, into that set of parentheses. I get x squared y prime minus y squared plus 2xy y prime equals 0. Now everything that's got a y prime I'm going to leave over on the right hand side. Everything that doesn't, I'm going to move over everything that has y prime I'm going to leave on the left hand side, and everything that doesn't have a y prime I'm going to move over to the right. So the x squared y prime and the 2xy y prime stay over on the left hand side, and then the y squared and the 2xy get subtracted over. Okay, so the next thing to do now is to find y prime. And we're going to pull the y prime out, and we get x squared plus 2xy in there. And then that's equal to y squared minus 2xy. And then we're going to divide both sides by x squared plus 2xy. So y prime is equal to y squared minus 2xy all over x squared plus 2xy. Okay, so now we need to take the derivative again. She's not going to be very happy, unfortunately, but it's that's something that we've got to accomplish. Maybe another easier way to do this. Not too sure. I'm not sure any particular way is going to be easy. Here we're going to be using the quotient rule. And the quotient rule is the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So let's try this out here. So f prime, so that's the derivative of the top. So y double prime is going to be equal to y squared, the derivative of y squared, which is 2y times y prime, minus 2 times, and then we've got the product rule again. So the derivative of the first times the second plus the first times the derivative of the second. Okay, and now that's all times the bottom, x squared plus 2xy. Okay, and then that's our, put the parentheses in there like that. Okay, so that's f prime times g. Okay, now we've got the second part here. Move that over, make that a little smaller. And then minus the top, so that's y squared minus 2xy, times the derivative of the bottom. So the derivative of the bottom is going to be 2x plus the derivative of the first, which is 1, times y, plus the first times the derivative of the second, which is y prime. Okay, close that all off, and then this is going to all be over the bottom squared. So that's all going to be over x squared plus 2xy. Okay, so now we're asked to find this derivative at the point negative 1, 1. So for x's, we're going to plug in negative 1. For y's, we're going to plug in 1. We need to know what to plug in for y prime. So I'm going to take and plug negative 1, 1 in for y prime. So y prime, first off, at the point negative 1, 1 is equal to 1 squared minus 2 times negative 1 times 1 all over negative 1 squared plus 2 times negative 1 times 1. So that is going to be equal to 1 plus 2 on the top, so that's 3 all over 1 minus 2 on the bottom, so that's negative 1, so that gives me negative 3. So wherever I see a y prime, then I'm going to plug in negative 3. So now, y double prime. So y double prime is equal to, all right, 2 times y. So you got 2 times 1 times y prime, which is negative 3, minus 2 times the sum of y, which is 1, plus negative 1 times negative 3. Close that, and then open 1 squared. That's negative 1 squared plus 2 times 1, which is negative 1, times y, which is 1. Okay. Minus y squared, which is 1 squared minus 2 times negative 1 times positive 1 times two times negative 1 plus 2 times 1 times y, so 1 plus negative 1 times negative 3. Okay. Let's make this smaller here so we can see everything. It's more of an exercise of keeping track of everything than anything else. All over the bottom squared. So then we get negative 1 squared plus 2 times negative 1 times 1. And that's all squared. So then y double prime is equal to, start cleaning this up, 2 times 1 times negative 3, which is negative 6. And then we've got 1 plus 3, which is 4 times negative 2, so that's going to be minus 8. And then that's going to be times 1 minus 2, so that's negative 1. Minus, and then in our first factor here, we've got 1 minus 2 times negative 1 times 1, so that's 1 plus 2, so that's 3, times negative 2 plus 1 plus 3, so that's going to be plus 8 there. And then all over. So we get 1 plus negative 2. So 1 minus 2 is negative 1. And that whole thing is squared. Okay. So now we've got negative 6 minus 8, which is negative 14, times negative 1, which is 14. And then negative 2 plus 8, which is 6, times 3, which is 18. So we get 14 minus 18 all over negative 1 squared, which is 1. And so that's equal to 4. So y double prime is equal to 4. Hopefully I didn't make any mistakes in that. Certainly let me know in the comments if I did. But that's it. That's y double prime at negative 1, 1. So if you have any questions, please put them in the comments below. I encourage you to try this on your own. Make sure that you can get the answer right. And if you have any other problems that you'd like to see done, please put them in the comments as well. Appreciate you watching, and I'll see you on the next problem.